Hey everybody, welcome back to AP Calculus AB videos, and in this one we're going to talk a lot more in depth about continuity and how it relates to limits. So remember that many times in order to take a limit of a function it has to be continuous. Well, why? Here's why. You have three conditions that need to be fulfilled for a function to be continuous. One, at a value of x equals c, so let me just note that down, f of x or f of c must exist, which means that it has to be a value that is not like infinity or does not exist. The second condition, the limit as x approaches c of f of x, or the limit as x approaches that value of the function, must also exist. And the third condition, they have to be equal. Only then is a function considered continuous. So go quickly over three cases of functions and determine whether they're continuous or not. Now, first function, f of x is equal to x squared. So, well, does f of c exist? Well, let's determine a c value for this function. We'll say c equals 4. For this one, we have a graph, so that won't matter. And for this one, we'll say c equals 0. And we can just say c equals 1 over here. So when c is equal to 4, does f of c exist? What is f of 4? F of 4 is 4 squared, which is 16. So we know the first condition is fulfilled because f of c exists. Now, does the limit as x approaches 4 of f of x exist? Well, what is the limit as x approaches 4? If you really quickly construct a graph over here, as x approaches 4, what is the graph approaching from both the left and the right hand side of the graph? That's still going to be 16, which means the limit as x approaches 4 of x squared does exist. And lastly, well, 16 is equal to 16, that holds true. Therefore, all three conditions of continuity are fulfilled. So at this specific value, our function here is continuous. So I'll just say continuous. Now moving on to our second example, well, we have a graph here instead of a function. So c equals 1. Well, what is f of 1 here? So f of 1, we'll just say 1 comma 1. So f of 1 is going to be 1, right? This is the filled up hole. This is the empty hole. Now, what is the limit as x approaches 1? Well, if you look at the graph, as x approaches 1 from the left, you're approaching this right there. But as x approaches 1 from the right, you're approaching 2 over here. So we know that 1 is not equal to 2. Therefore, this limit right here does not exist. Now, because this does not exist, we don't need to check whether the last condition is true. Well, to be truthful, you know that last condition is not going to be true because one of these values does not exist. So this is not continuous, which also means that you cannot take the limit at 1 of this function, because as we determined, it's not continuous there. And that's going to play a big role into a future concept that we learn, which is called derivatives. So going on to the last example, well, we have a function here, and we can actually simplify this one. So canceling out these 7s, take out an x, you're going to get this function to be 1 over x. If c is equal to 0, our first condition right here is 1 over 0, which is undefined. So therefore, this function is not continuous. Now keep in mind that when I say not continuous, that usually pertains to some sort of interval from a to b. But over here we're talking about specific values. So at 0, this function is not continuous. But if you were to pick any other value, notice that 0 is the only number here that would get you a value that does not exist. If you were to pick any other value that is not 0, this would be continuous. Or we could at least try to prove that, but this first condition would work in this case. 1 over 2, 1 over 3, 1 over 4, etc. Those would all exist, at the least. So we would have to take the extra steps again to check whether it's continuous, but we would know that f of x exists. Now, let's say we want to test continuity over an interval. Let's say we want to go from 1 comma 2. Well, how do we check that? Well, we have to solve for the values that specifically make this a does not exist value. So what I'm saying right here is, when does 1 over x result in a value that does not exist? That only happens when x is equal to 0. Therefore, since 0 is not between 1 and 2, f of x over here is continuous on that interval, is continuous on the interval 1, 2. So that should give you a basic idea of what continuity is. Now, looking at a graph really quickly before we end the video, you'll usually see maybe like some really weird graph like this. And it might be pretty hard to determine whether this is continuous or not if you're not given the function, but you can really just look at the graph and see, well, if there are no holes or just random jumps or breaks in the graph, this is almost always going to be a continuous function. So starting in the next video, we'll do some examples about limits and continuity, and we'll try to go over some basic theorems concerning both. And then we'll delve into derivatives.